Let's get started. I would like to introduce KYZEN's Applications Lab Manager, Chelsea Jewell.
Hi, everybody, and thank you for joining us today. As Chelsea said, my name is Chelsea Jewell, and I'm the Application Lab Manager here in KYZEN, Nashville. And today we're going to talk about chemistry selection, or more importantly, how to match your soil to the right chemistry. So, my job at KYZEN revolves around one question: what chemistry works for my process? Well, it depends. Everybody's favorite answer. In order to determine the best match for your process, we have to reduce the process down to its most basic job. Bringing into that, for your cleaning process, we have 4 variables when it comes to cleaning, or as we like to refer to it, TEST. This simply means temperature, energy, solubility, and time. All of these factors combine to create your cleaning process. For today, we're going to focus mainly on solubility. So, what is solubility? Simply put, it's the amount of a substance that will dissolve in a given amount of another substance. As you can see in our images here, on the left-hand side, we have Alka-Seltzer that's moved into solution and is dispersing evenly, whereas on our left side, we have oil droplets that are forming layers and bubbles and not pulling into the solution. So what does that mean for electronics? A soluble match will look similar to this image, where you see the troughs are clear of flux residue, there's nothing remaining on the bumps, and overall, we can't find any flux remaining. As opposed to an insoluble match, you'll see in some of the troughs between the pads, there's clear residues. This means the chemistry didn't affect the flux residue at all, and around our troughs, it's a white chalky flux. This denotes a poor match or an insoluble flux and chemistry combination. So, in order to determine a successful cleaning process, we have to see what dissolves the soil first. At KYZEN, we do our Hansen solubility test. In the lab, we perform a number of basic solubility tests using simple PCBs that are FR4. We put any flux or solder paste on them and reflow them through our oven. From that point, they're cut into coupons and then placed into test vials with various chemistries. Those vials are then put onto our wheel and it's spun at a known rotation, either in the oven or at room temperature, depending on what chemistry we're working with. So, what this test allows us to do is it scales back from using a machine and takes the mechanical energy aspect out of the process. What we see then is a combination of how a specific flux responds to the chemistry. So, some of the things that we talked about with Hansen solubility is it determines the specific solubility of a soil with a chemistry. It removes mechanical energy, so we see a true match between the two products. You're also able to run many chemistries at the same time, and you can see how specific flux react without using production board. So this is an overview of our grading scale for Hansen. Starting with our 6th score, you can see that the flux is still shiny, there's no white patches or any indication that the chemistry has affected the residue at all. So we say this is a 6 or no effect. Moving on to our 5 through 2, you can see that the flux is starting to be removed, and at each step it gets better and better. In our 3, you see a little bit of white residue, so it's starting to respond. Then our 2, there's just a minimal amount of residue left in the troughs. Finally, up to our 1, which is our perfect score, or there's no residue remaining. When we go into the analytics of this and what our recommendations are, you know, a 1 is a perfect match. This means that when you move into the next phase of your process, it's going to clean well. 2s, typically we can say that as well. When we get into that 3 to 4 range, that's when we have to start pulling in other aspects of our variables or a test method in order to improve that cleaning result. This type of test can also be adopted in your maintenance cleaning. As you can see on the left, the solder paste has been put into a vial with chemistry and it's dispersing throughout the solution. If you were to take the vial and move it back and forth, you would see the solder paste moving and disperse throughout the solution. This indicates a soluble match or a good cleaning combination. On the right, you'll see the solder is pulled up at the bottom of the vial. It's almost rejecting going into solution, and we would consider this an insoluble match. Your cleaning chemistries can also depend on your flux type. So if you're looking at a no-clean application, aqueous, semi-aqueous, and solvents are all possible matches for your soil. The same goes for your rosins or RAs. Rosins are typically really happy with semi-aqueous and solvent chemistries. Moving on to our water-soluble, of course aqueous will do a good job. Most semi-aqueous will have an effect, but when we get into solvent ranges, that can cause some issues or some incompatibilities just because the solvency isn't the same for a water-soluble flux in a non-water chemistry. Because of the design, we have adopted aqueous products for water-soluble chemistries that are able to penetrate underneath low-gap components where water typically can't because of the surface tension. If you're curious about water-soluble cleaning, please consider joining us for Charlie Pateris' session on January 21st. Just visit Tech to Tech by KYZEN to sign up. So now that we've stepped through and we've found multiple combinations for our soil, it's time to start adding back in our process variables. So what machine are you looking at? Do you have a machine in place? Does it need to be immersion or spray depending on what your product selection was? Are there temperature considerations? Is there a sensitivity on the board that it can't go above certain temperatures that we need in the cleaning process in order to get that perfect score? So that's another variable we have to consider. Are there water sensitivities? I have multiple customers have sent me substrates that can't be put into water. So at that point, we move to our dual solvent or a solvent-only cleaning process that takes the water out of the equation. Metal compatibilities. I feel like this comes up quite a bit. You know, if I take my temperature too high, I'm discoloring copper or aluminum, but I can't clean the flux if it doesn't go up to that temperature. That typically indicates that we should have a better match with the chemistry to help fix those problems. Your time post reflow. Typically between rosins and no cleans, we don't see a lot of variation in our time post reflow when you clean, but with water solubles, it can be a big deal. You can have a completely different flux residue on the board after a couple hours or a day even than what was originally seen post reflow. Part markings and label compatibilities are also a big concern. Over the years at KYZEN, we've done hundreds and hundreds of label compatibility tests with pretty much all the major label companies out on the market. Please feel free, if you have questions, reach out to us on label compatibility, and we can direct you on what chemistry would work and would help that process. So going into our benefits of solubility testing, it can definitely expedite your evaluation. Rather than having to take a whole production line down just to see if maybe this chemistry will work, we can jumpstart that process. We can say, hey, these are the couple options that we believe will work, and move forward from there. You can also observe specific reactions to the chemistry. Do you see the flux clinging to the solder bond, or is there more flux staying in the trough and connecting to your FR4? What issues do you see there? This type of testing can help see any potential problems we might see later down the line. Understanding what mechanics will be needed to get you to that cleanliness you're looking for. When we looked at the grading scale, there was some areas there that weren't quite perfect. A lot of times we can tailor the cleaning process to overcome any of those compatibility issues. You're also able to evaluate multiple products simultaneously. So if you have different fluxes on the same board, you can see how that reacts. So KYZEN has performed tens of thousands of Hansen solubility testing on soils. So if a lot of times we get the products before they even hit the market from the solder paste companies. Please feel free to ask us if you have questions on specific materials. And with that, I'm going to hand it back to Chelsea. Thank you for your time.
Thanks, Chelsea. If you'd like to discuss this topic further, please contact your local KaiZen regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.